In this video, we're going to have a look at creating a simple RTS-like camera in Unity. We'll create functionality for panning around the world using both the keyboard and the mouse. We'll also have a look at scrolling to zoom in and out. We'll also have a look at how you can put boundaries on your camera. And towards the end of the video, we'll talk about how you can get more advanced functionality. So let's get started. So in this video, we're going to be using the FPS desert environment as an example scene. If you want to get this for yourself, you can go to devassets.com, click on the FPS environment, and you can see some of the images, read a bit about it. And when you're ready, you can choose a price and hit the blue button. Once you download it, simply unzip it and double click on the Unity package and it's going to open everything up for you. You can then just open the example scene and you should be good to go. Now what I've done for my camera is I've put it pretty much in the center of the scene. I've pulled it back a bit on the Z and I've pulled it up on the Y. Mine is currently sitting at about 60 units. I've given it a rotation of around 60. Some people like to do a completely flat view, meaning 90 degrees. Other people like an angle. It's going to totally depend on your game. Now I've left the projection at perspective, but you can always change it to orthographic to get a completely different look. I'm just going to leave it at perspective though, and then set the field of view around 40. Now we can go and add a new component. Let's call it the camera controller. Let's hit new script, hit create and add. Let's open this up in Visual Studio. Now there are a bunch of different ways of going about creating a camera controller. That's because both input and movement in Unity can be handled in 1,000 different ways. We're just going to have a look at creating something really simple that works, and then I'll talk about how you can expand upon this later. So let's begin by removing our two using tags at the very top. And let's also remove our start method. Let's instead add a new public float. We'll call this one panspeed. This is going to specify the speed at which we'll move our camera across the world, and we'll default this to something like 20. And so our camera will move at a speed of 20 units per second. We'll then go down into the update method, and first off we want to be able to move using the keyboard. And so we'll create an if statement here to check if input.getKey, and the key that we want to check for is going to depend on your game. I just want to move using the WASD keys. So I'm going to check for W, and each time we press this key, we want to move a little bit forward. Now we could go in here and use transform.translate. This would allow us to move our game object in the specified direction, but we probably want to be able to move in multiple directions. Say if we're holding down both W and D, we want to move both up and to the right. And if we're also scrolling, we want to be able to zoom in and out at the same time. Of course, we could just call transform.translate multiple times during the update, but I think a cleaner way is to up here get the current position of our camera. We'll store this as a vector3. We'll call it pos and set it equal to transform.position. So now we have the x, y, and z coordinates stored in this pos variable, and then edit these position coordinates. And then once we know our new position, how much we need to move in the different directions, and how much we need to zoom in or out, then we'll update our position. So for now, we'll just be changing the variable. We do that by saying pos dot, and then we can change the different coordinates. We want to move forward, and so we need to modify the z component. We'll add on to that, so we'll say plus equals pan speed multiplied with time.delta time. We want to add pan speed because the amount of units we want to move is going to depend on our speed, and then we multiply with time.delta time to make sure that no matter what frame rate we're currently running at, we're going to move the same distance. Time.delta time is simply the amount of time elapsed since we last drew a frame, and so if we draw a lot of frames per second, this number is going to be small, and therefore we're not going to move that much each frame call, and if we only draw a few frames a second, time.delta time is going to be larger, and therefore we're going to move a greater amount each frame. And so we make sure that we move relative to time and not to frame rate. Of course, we also need to apply our new position. So we go transform.position and feed back in our position variable. So what we're doing is we're storing our current position in a temporary pos variable. We check if we press the W key. If so, we want to move forward. And so we increase our Z value, and then we set our current position equal to our new position. So let's save this, head back into Unity, and when we now hit play, we should be able to press the W key and then move forward. Awesome. But we can't move in any of the other directions, and we can't use our cursor to move. So in order to use our cursor to move, we want to create a new variable. This is also going to be a public float, and this is going to specify how close we need to get to the edge of our screen before the camera moves in that direction. We'll call this one the pan border thickness. And we'll set that equal to 10. Then down here in our if statement, we need to say that we want to move forward if we press the W key. And these two vertical bars mean or, so that the if statement will be true if this is true or the next condition is true. And here we want to get the current position of our mouse. So we'll go input.mousePosition. And this is the current mouse position in pixel coordinates. and it records pixel coordinates from the bottom left corner of our screen. So what we need to check for is whether or not our mouse position on the y-axis is greater than the height of our screen minus our border thickness. So we'll do that in here. So we'll say if our mouse position .y is greater than or equal to our screen .height, and this is our screen height in pixels, minus, and then the pan border thickness. So if we now save this and head into Unity again and hit play, we can see that we can move using W and by moving our cursor to the top of our screen. And you can see that we don't need to touch the edge as long as we get within 10 pixels. Awesome. So now we simply need to add this to the other directions as well. To do that, we simply duplicate this if statement, paste it 3 more times. And for the second one here, we want to check if we want to move back. So we'll press S, and we'll only do this if our mouse position is less than or equal to the pan border thickness. Now remember that because our origin is at the bottom, we no longer need to use screen.height if our Y position is less than 10 pixels. And if it is, we now want to subtract the pan speed multiplied with time.delta time. So we just want to move in the opposite direction. If we want to move to the right, that means if we press the D key, we want to check if mouse position.x is greater than or equal to screen.width minus pan border thickness. And we still want to move in the positive direction, but we now want to do it on the x-axis. And to the left here, that means A, we want to check if mouse position.x is less than or equal to the pan border thickness. And again, we want to move along the x-axis, but in a negative direction. And notice how we can make all of these changes to our variable and only update our actual position once. So let's save, head into Unity and hit play, and you should now see that we can use the vast keys to move and the mouse cursor as well. And we can even combine the two if we want to. However, we have one more problem, and that is that we are currently able to move really far in any given direction. And most games probably want to limit how far they can move away from the map. Of course, this limit is going to depend on your map size, so let's make a few variables to adjust it. We'll go inside of Visual Studio, we'll make a few lines after we change our position. We do this one axis at a time. So let's begin with position.x. We want to set this equal to math.clamp, and clamp simply allows us to limit a number between a minimum and a maximum value. We'll first off write the value that we want to limit. In our case, that's position.x. Then we want to write the minimum value, and of course we could hard code this in, but instead let's go up here and create a few variables. We could go ahead and create 2 public floats, one called xlimit and one called zlimit, but something I find a bit cleaner is simply using a vector2, which of course stores both an x and a y value. Then we can simply map the y value onto the z component. So in our case, we'll go ahead and call it something like pan limit, and let's close it off and set it in the inspector. So down here as the minimum value, we'll have negative pan limit.x, and as the positive value, we'll have positive pan limit.x, and close that off with a semicolon. And we'll do the same thing on the z. We'll have pos.z equals math.clamp, and the value we want to clamp is pos.z, and we want to clamp it between negative pan limit, and here we write .y, but it maps to the z, comma, pan limit.y. So now if we save this and head back into Unity, we'll get 2 values that we can adjust, one for the x, and I want to be able to go 40 units on the x-axis in either direction and 50 on the z. So let's try and hit play, and as you can now see, we can only move to negative 40 on the x and negative 50 on the z. Cool. So the final thing that we'll be adding to our script is a way to scroll. And here we want to use something that Unity has set up in the input manager for us. If we go edit, project settings, and then input, we can see the different axes Unity is set up. One of them is the mouse scroll wheel. This simply detects when we scroll the wheel, how fast, and in what direction. So let's copy the name, mouse scroll wheel. Let's go into Visual Studio, and let's get the value of the scroll wheel on this particular update call. We do that by going input.getAxis, and then in quotation marks, inserting the mouse scroll wheel axis. We'll round it off with a semicolon, and we want to store this in a variable. So we'll create a float, call it scroll, and set it equal to input.getAxis mouse scroll wheel. Then let's go to the top and add a variable for controlling the scroll speed. We'll create a public float scroll speed and set it equal to something like 2. And then right after we get this variable, let's change our y position. So we go position.y plus equals scroll multiplied with scroll speed multiplied with time.delta time. And we probably need to flip the direction on this, but let's just try and hit save and see if it works. So if we now hit play in Unity, we should be able to scroll in and out. But we're scrolling really slowly. So what I like to do is go in here and hard code 100 on top of this and then go up here and add a 0, just so our pan speed and scroll speed are around the same value. Then we can also go into Unity, select our main camera and make sure to update the scroll speed there as well. Let's hit play and now we're able to scroll in and out, but it is definitely reversed for me, so I'm just going to go in here and change this to negative. Finally, we can also clamp our Y position so we can't scroll inside of buildings. To do that, we simply go up here and we add two new variables, a public float minimum Y and a public float maximum Y. I'm going to set the first one equal to 20 and the second one equal to something like 120. Let's scroll down and here we simply add another line. We go plus.y equals math.clamp. The value we want to clamp is plus.y and we want to clamp it between minimum Y and maximum Y. And let's close that off with a semicolon. So now we've added all of the code that we need to add. We can pan with both the keyboard and the mouse. We can scroll using the scroll wheel. We can control the speed at which we pan and the speed at which we scroll, the thickness of the borders around the window, limit both our position and our zoom. So let's now go back into Unity and try all of this out. We can fly around. We can scroll, but not too far. We can use both the keyboard and the mouse. And of course, there's the limit to what we can do. Awesome. So this was a pretty basic overview of how you can create an RTS-like camera controller. However, there's still a lot of features that modern games often use on their camera controllers. So I searched around a bit and actually found a very good asset store plugin called RTS Camera that makes it easy to do all of the stuff that we already have added, like keyboard input, screen edge input, scrolling and movement limiting. But it can also do stuff like panning when holding down the mouse, following a target, rotating based on the keyboard, and even automatically adjusting height depending on the height of what you're currently viewing. It also adds a bit of smoothing on the camera so everything looks a bit better. So of course have a link to this in the description. So that's pretty much it for this video. If you're making an RTS or some other game that requires AI, definitely subscribe because I'll be creating a video on the new Unity AI/nav mesh system as soon as the high level components get released. Other than that, thanks for watching and I will see you in the next video. Thanks to all of the awesome Patreon supporters who donated in March, and a special thanks to Derek Heemskirk, Faisal Marify, James Kellhound and Jason the Tito. If you want to support the channel and become a patron yourself, you can do so at patreon.com/Brackeys. Thanks a lot, guys.